Hey everybody, and welcome to another online lesson. We're going to just get right into it with 10.6 circles and arcs. So you'll recognize that we are skipping 10.4 and 10.5. So we're going to be jumping right into 10.6. We're going to be talking about circles and arcs. As a little introduction problem, we got a tire here. The bicycle wheel shown at the right, it travels 63 inches in one complete rotation. So that complete rotation is called the circumference. Okay, the circumference of a circle is the distance around the entire circle. So if I do a complete rotation and it takes me 63 inches, well, that is the circumference of the wheel. But if the wheel only rotates 120 degrees about the center, how far does it travel? So if it only goes 120 degrees, how far does it go? Well, here's the basic idea of what we're talking about. It traveled 120 degrees of 360 degrees of a circle. A full rotation of a circle is 360 degrees. So how much of the full rotation did it go? We can get rid of the zeros, and you can call that 12 over 36. And 12 goes into 36 3 times, so that equals 1/3. So it is 1/3 of a full rotation. It traveled 1/3 of a full rotation. So how far did it travel? Well, if one full rotation is 63 inches, all we have to do is take 1/3 and multiply that by 63, and we get how many inches it traveled. So it's really 63 divided by 3, and 63 divided by 3 is 21. It traveled 21 inches. So we have two things going on in this problem. We have the full circumference of the circle, and we have what's called a piece of the circumference of the circle, which is called an arc. So the main idea, we have a circle, okay? The distance from A all the way to B is called the diameter. The diameter must pass through the center of the circle P. We have what's called a radius. A radius travels from the center of the circle to the edge of the circle. It takes 2 radii to create 1 diameter. But we also have an angle. It's called a central angle. A central angle is created when you go from one edge of the circle to the center back to the other edge of the circle. This right here is called the central angle, or you could call it angle A to P to C. We also have what is called arcs. We have minor arcs and we have major arcs. So the central angle is the actual angle inside of the circle, but the arc is the distance from A to C. Or if you look at this circle here, you'll recognize the symbol for arc. It takes 3 letters to draw or write an arc, okay, a major arc. We have 2 different kinds of arcs here. We have major arcs and we have minor arcs, okay? A major arc must be more than 180 degrees. So a major arc must be greater than 180 degrees. If you have an arc that is equal to 180 degrees, that's called a semicircle. A semicircle. If you have an arc that is equal to 180 degrees. And then you have a minor arc. And minor arcs are less than 180 degrees. So here you have a minor arc. A minor arc travels from R to S. So the arc is literally the distance around the side of the circle here. You'll recognize it's not measured in degrees. It'd be measured in whatever the distance of the circle is, feet, inches, whatever. So, and then you have a major arc. A major arc takes 3 letters. You would travel from S to T, but then continue traveling all the way to R. That would be the major arc. A minor arc would be traveling just from R to S, or you could say S to T. All right. First example problem, we're going to be talking about arcs. What are the minor arcs of circle O here? So we have minor arcs. A minor arc, again, must be less than 180 degrees. So we could have the minor arc A to D. We could travel from A and we could stop at D. That would be less than 180 degrees. We could go A to C. A to C. That'd be a minor arc. We could go C to E. And we could go E to D. But if we traveled from A all the way to E, that would not be a minor arc. The arc of A to E would be called a semicircle. Because it literally cuts off half of the circle. So also would be C to D. What are the major arcs of circle O? But these major arcs must contain point A. So remember, a major arc must be larger than 180 degrees. A major arc must be greater than a semicircle. So if I'm going to contain A, I'd have to go D to A. I can't stop at C. That would be a semicircle. So I'd have to go D to A all the way over to E. So D, A, E would be a major arc. I could also go C to E to A. That would be another major arc. I could go A to C to D. A to C all the way over here to D. That would be another major arc. And every one of these major arcs is larger than 180 degrees. And they are also containing the point A. Sorry, I lost my train of thought there. They are also containing point A. All right, go on to the next page. The measure of a circle's minor arc is equal to the minor arc's angle, the minor arc's central angle that creates it. So look at this picture here. We have this central angle here, which is 50 degrees. Okay? We have this arc here, R to T. Well, this is 50, therefore R to T is also 50. We could also say that the measure of the whole entire thing would be 360 minus what 50 is. So therefore, T to Q to R would be 310 because the entire circle is 360. The measure of a major arc is found by subtracting the minor arc from 360. All right, try another example problem. What is the measure of each arc inside of circle O? So we want to know what the measure of arc B to C equals. So here's B to C. B to C is right here, but the central angle is B to O to C, which is 32. So therefore B to C is also 32. Then we'd have C to D. C to D is 58. That means that this angle inside, that central angle here, must be 58. So we already have C to D. We know that C to D is 58. Then we have D to A. This arc out here, D to A. Well, how are we going to figure this out? Well, this is a diameter. So therefore, if this is 58, I can take 58 and subtract it from 180 to get what D to O to A is. And 180 minus 58 is 122. So this angle here is 122. So that means that D to A must equal 122. And then last but not least, we have B to A. Now there's a couple ways you could find B to A. We already know that all of these are this portion of the circle. So therefore, how much more of the circle do we have to go before we reach 360? So you could say that B to A, and that needs to be an arc symbol, B to A could equal 360 minus all of the others. Minus 32, minus 58, minus 122. So 360 minus 32 minus 58 minus 122 is 148. Or you could have said 180 take away the 32, which is also 148. The circumference of a circle is the perimeter around the circle. The equation for circumference is C equals 2 pi r. C equals 2 pi times r. This is extremely important. C equals 2 pi r. Circles that share the same center are called concentric circles. So this circle 8 inside of here has the same center as this circle on the outside. However, they have different radii. Okay? We're going to use that idea here. A car has a circular turning radius of 16.1 feet. The distance between the two front tires is 4.7 feet. How much farther does a tire on the outside of the circle travel than the tire on the inside of the circle? So as this car turns around, the two outside tires create a larger circle than do the two inside tires. We want to know how much larger are the outside tires. So we need to take the big circle's circumference and subtract the small circle circumference. The circumference is 2 pi r. So we need to figure out what the radii are. We know that the distance from here to here is 16.1 feet. That is the big circle's radius. So it's 2 pi times 16.1 minus 2 pi, but now we need the little radius. This is the little radius. We know that this distance is the little radius of the circle, but the whole entire thing is 16.1, but we know that this distance is 4.7. So how do I find little r? If that distance is 4.7, you would take 16.1 and subtract 4.7 to find the little r right there. So 16.1 minus 4.7 is 11.4. So then we would take 2 times 16.1, 32.2 times pi, and we'd subtract 2 times 11.4, which is 22.8. We could subtract these, 32.2 minus 22.8 is 9.4 pi, which would be estimated, if we want to multiply by what pi is, 9.4 times pi is 29.53, rounded to 2 decimal places, feet. So the outside tires, as this car drives in a circle, the outside tires actually travel 29.53 feet further than the inside tires travel. What is the length of major arc X to P all the way over here to Y? This brings us back full circle to our original problem. How far is this distance if we know that the arc of it is 240 degrees? What does the distance of this thing equal? Well, 240 degrees of how much of the entirety? 360. So then we can reduce this. 4 goes into 8, goes into both of them. 24 over 36 reduces to 2/3. So this distance here is 2/3 of a full circle. So then the whole idea is well, what is the full circle? The full circle is 15 radii. So then the full circumference would equal 2 times pi times 15, which is 30 pi. But what do I need to do with this full circumference? I have to multiply it by 2/3. 3 divides into 30 10 times. 10 times 2 is 20 pi. So the full distance, the distance of X to P to Y, is 20 pi centimeters, which you could round that if you wanted to, if they tell you to. Actually, it tells you, leave your answer in terms of pi. So this is our answer in terms of pi. But if you wanted to round that, if it tells you to round that, you would just take 20 times pi on your calculator and get 62.8 centimeters. That's the rounded answer, but this particular problem does not ask you to round. It wants the exact answer of 20 pi. So there you go. That is circles and arcs and minor arcs and major arcs. Remember, minor arcs must be less than 180. Major arcs must be greater than 180. If you are equal to 180, that's called a semicircle. So spend some time this week going over these notes and get on to Math Excel and do 10.6 Math Excel assignment. There's going to be one more week of notes, I believe, and then we're going to take our next test. Once again, if you want to improve your grade in this class, these are the only assignments that you have to do that. So make certain that you are doing these to the best of your ability. All right. Thanks, guys. Have a great week. Bye.